All right, welcome back to tutorial series number 4 of starting or building a web interface for the TR1. This is part 4. If you haven't been following along, check out the earlier versions. But basically, we are building something in the browser that we can use to control the actual TR1 robot. And what you see right now is the current client with a backend that is using Gazebo to simulate all of the physics and even the camera, which you're able to see here. As we move around, we can see, everything that's going on. So we're working on a whole bunch of features here, so stick along for that. So what we've got right here in front of me is what I currently have built. Where we're at currently in the tutorial series, last time where we left off, is just getting started with building out the client. Okay, so what we have here in front of us, we have built out the server. Okay, we haven't tested anything yet because we don't have the ROS launch files in order to fire up all of the dependencies in a really easy way. So what we're going to do today is we're going to start off by building our ROS launch files. Then we can start to test and run our backend server and make sure everything's working properly. And then finally, we can, and what we'll be doing for most of the video today is working on the actual front end, working on all of those objects, those classes, and we're going to be drawing everything that you see here in front of us with p5.js. This is the most fun part, is building the front end client. And so this is going to be a good video. Appreciate you sticking along. One other thing, I've got a new camera in my office. As you can see, I've got TR1 right in here with us. So once we get this whole software, the front end, the back end, everything working just how we like it, we'll be able to take this and run it directly on the TR1. So this is how we're going to be doing some of our stuff like that. So stick around. Might be a couple episodes before we get to it, but we are doing well. Okay, so let's stay here. Okay, so let me close out of this. And what I've got here is our current sketch, a bunch of empty files, and so we've got just a bunch of empty classes that we're going to need to build out. And let me move me back down here. There we go. And so that's what we're going to be working on today. We're going to be filling out some of these classes. We're going to be creating our little sketch file, which is going to be where, it's just like Arduino, right? If you've worked with that, you have your main setup function, then you have your main loop. So that's exactly what we've got here. We've got a one-time run function with setup, and then draw is just this continuous loop that goes through. So it's great. It's a great little platform framework, whatever we want to call it. So as mentioned, let's start off with the launch files. Okay, so let's go over here. We are working within TR1 control center _tut, and we already have a launch folder. Great. So let's change directory, ROS workstation, source, TR1 control center tut, and then we're going to go into launch. Now we're going to create a few files. Touch, let's see, what are these called? Yeah, just TR1 control center .launch. And then we're also going to create another file, TR1 control center sim.launch. Because whenever we run the simulation, we're going to be needing to load up quite a few extra things, but we're going to need all the Gazebo dependencies and all that kind of stuff. And so two separate things that we're going to launch, but it's all going to work pretty similarly. Okay, so now that we got those files, we can move that over into gedit. Get it. I presume it's pronounced gedit. And let's go ahead and get this going. I'm going to just copy and paste stuff in one by one because it's really not that complicated, and we might waste a lot of time if we don't do this. Okay, so we are working on Tier 1 Control Center sim.launch. So we'll go ahead and create this first, and this is going to be our launch file that we can actually run. That is going to load all of our dependencies for running the Tier 1 Control Center within a simulated environment. We have a couple arguments here. Most of these, in fact, all of these right here, I believe. Yeah, all of these right here are, in fact, arguments for Gazebo. Once I show you the launch or the node for loading Gazebo, yeah, it's actually we're loading up a separate Gazebo ROS launch file, and these are all arguments in there. So this is we're just passing these through basically, and then the server argument is what we're going to use for. It's basically just a true or false. Should we load the actual web server for Tier 1 Control Center? Now, the reason we have an argument for that is because whenever you're doing development, I found most of the development here is actually on the server and on the front end, right? So if we have this argument, we can launch the file with everything except for the server, and then on a separate tab in terminal, we can actually launch the server itself. So that way, we don't have to reload the entire Gazebo environment, all of the controllers, all that kind of stuff. That takes a lot of time. But this way, we're able to really quickly iterate, make some changes, see if it worked, bounce back and forth, that kind of thing. Okay, so now we've got some parameters. These are all Tier 1 hardware interface parameters. And let's see. We've got a robot description, which is in Zacro. Find Tier 1 description robots, tier1.urdf.zacro. And so nothing crazy there. We're just loading some things into the parameter server. Here's our include section, where we are going to include the Tier 1 tools go-to-position launch file with the sim argument equal to true. This is where we have a little bit of inconsistency in just the way that we've organized some of this. Probably we should separate this into a separate launch file. So some of you early folks that are joining us on this journey might have to put up with a little bit of changes or a little bit of inconsistency in the way we've done that. But we are committed to getting better. Okay, and then lastly, we've just got our nodes. And of course, here's our Gazebo launch file with all of these arguments that we've described up here. Except for control. That's actually a Tier 1 hardware interface argument. Yeah, which is this right here. Okay. As far as our nodes go, this is loading up the controller spawner. We're loading trajectory controllers for the right and the left arm. We've got position controllers for the grippers, effort controllers for everything else. This is our web video server. So this is actually another ROS package. It is on ROS's wiki page, so you can install it just with ROS, sudo apt-get install ROS kinetic web-video-server. So this is a package that actually will allow you to select a particular image topic, and it will spin up a server with just that video or that image feed, which is fantastic so that's how we are able to use the Gazebo environment and we're able to display that within the browser, is because we've used this web video server to just create the video for us of the camera feed on the robot, and then we can just point the front end over to there. There's a little bit of reworking there because this works really well in Google Chrome. I've noticed with other browsers it doesn't work as well. So keep that in mind. If you're having any issues with this, we're going to be reworking that probably, where we actually pass all of the pixels or something like that. I don't know. We'll have to think about performance and how all that's going to work. But that's where we are for now. This is going to be loaded up on port 8081. So this is our actual Tier 1 control center node, right? So this is actually the web server itself. And you can see that it's only running if server is equal to true. So if we set server equal to false, then it will not run. Also take note, and I'll get into this once we actually launch everything, we're going to be launching this with GUI equal to false. And that just means that Gazebo is going to launch without the GZ client, without the Gazebo client. So it's not going to load the screen that actually displays everything. That just helps for performance because we're already able to see what's going on within our web browser. It actually works a lot better performance-wise doing it that way. Just loading in the browser as opposed to loading it on the client. So robot state publisher, that's pretty basic stuff. And then we're launching Gazebo ROS node. Yeah, this is just spawning our robot URDF. Okay. Easy peasy there. Let's see. And then we'll do TR1 control center at launch. This probably will get reworked a little bit in the future, but this is where we're at currently. Launching TR1 hardware interface, launching TR1 go to position. We're launching the Astra, Orbeck Astra launch file. So this is, I believe this is just publishing, yeah, this is publishing the image and depth ROS topics from the Orbeck Astra, which is the actual camera we use on the TR1 hardware. Web video server, we've seen that. And TR1 control center, we've seen that. So this one ends up being much, much simpler. But we're actually not going to use that quite yet because we're still working in the simulated environment. Okay. Okay, so how do we actually launch these? So again, we're going to go into our ROS launch. We're going to do TR1 control center tut. And then, which is our package. Now we're going to select our actual launch file. And it's going to be sim.launch. Now we're going to provide a few arguments that I mentioned before, right? So we're going to set server equal to false. And we're also going to set GUI equal to false. So that we're not going to launch our web server. We're not going to launch our Gazebo client. And here's where we cross our fingers a little bit. Ooh, I know what we did wrong. It actually hasn't shown an error yet, or an error that we should care about. But I realized that we are likely not pointing to the correct TR1 control center because I have two now right now. You know, I've got the TR1 control center underscore tut, and I've got TR1 control center. So let's try that. Let me also double check my CMake lists. TR1 control center tut. Okay, it looks like we've probably got the names correct there. Okay. TR1 control center tut. Yeah, that should be good. That should be good. So we'll try that out. Of course, I'm running it separately. I don't think that actually did much. Yeah, that probably didn't do anything. But if we ever want to run this without running the server separately, I just saved us a little bit of hassle. Okay, great. So we'll go to the browser, we'll reload, ta-da, there's nothing, right? Because we don't have that web server running yet. And if we go to 8081, we'll actually see that there are our ROS topics right here, or our image video stuff. Man, my throat, sorry about that today. Forgive me. Okay. Actually reload that. Okay, yeah, so it's actually not loading. Okay, so now that we've got all of our dependencies running, now we can run our actual server. And we're going to do that through ROS run. we're going to do TR1 underscore control center tut, and then we're going to, no, we don't want to display everything, and then it's just TR1 control center .js, and there we go, listening on port 8080. Reload. There we go. Okay, so where we left off last time was actually with this sketch where we're just drawing a rectangle. We've got this black background, and that's it, right? Just to prove that we're actually getting somewhere. So now that we've got all of our raw stuff figured out, now we can just focus on the front end. Okay, 15 minutes. Man, time flies, right? So let's see what we can do for the next 15, 20 minutes or so. Probably should mute my phone. Apologize. Okay. So, our sketch file. You got to be careful with this kind of stuff to not make the sketch file too big. The sketch file is the easiest place to put stuff. You have some code, you want to draw something, you want to, handle some sort of event. It's like, just throw it in the sketch file. Okay. The sketch file, as it currently sits on my actual, where I'm at currently with this, is 55 lines long, 56 actually. Looks like that's a little bit too long, frankly. There's probably some stuff going on there, but you want to try to make, in my opinion, the sketch file as simple as possible. You want all of your files to be pretty short. So we do, if we're going to define a global variable, I think in general this is the way to do it. Now that I think about it, you could, so I'm going to define, for example, a menu object. And we're going to go in here and we're going to create the actual menu object. I could actually define that here, but I don't know. That's kind of more of a design choice. We can go back and change that later if we want. So we're going to define all of our main objects that we're going to be using. Viewer, drop down menu, which we'll get to that later. Our terminal. Okay, so these are our main objects, and it looks like probably missed map. Okay. And then in our setup, basically what we're going to do is we're going to go into menu, we're going to do new menu, right? Like we're just going to do that for each one of our classes here. Oops. Map equals new map, robot equals new robot, etc., etc. And then we're going to go into each one of these files and describe actually what's going on there. And then down here in our draw section, we're just going to run like a step function. So we're going to do viewer.step. We're going to do robot.step. Right? So we're just iterating. Okay? Each time this draw function runs, it's like update your state one step. And for some of the objects, there may not be anything that actually goes on. But let's say an event happens, or that's where all of your calculations done. And that's kind of how you're just working through iteration after iteration. That's just kind of the progression of time here. Okay. So let's go ahead and finish all this out here. And this is easy for me, right? Because I've already thought about what I want. In the future, you'll be able to see a little bit more of like, okay, so I want this. How are we actually going to be able to go through and build that out? So I look forward to that. And you're probably not going to be this like, it's much more exploratory when you're actually like sitting down and programming. But it turns out actually sitting down and programming, like all of this, took me much more than just like 3 or 4 hours, and probably wouldn't be terribly interesting or helpful to watch. Okay, so I'm getting a little distracted. So drop down menu equals new. Let's drop down menu. already got new map. Let's see, menu, robot, map, robot, viewer. Okay. Terminal equals new terminal. And then down here we can just step. And the order may matter here, right? You know, if you've got, let's say and I can't remember if this is actually the case or not, but let's say we've got this robot object, and it depends, in order for the robot to know what to do next, it has to know what the viewer has just done, right? So that there might be some order that matters here. Map.up, or map.step, and terminal step. Okay, so there's some of that. We're going to have some event handlers down here. Okay. There we go. Okay, so and what we can do here is with, you know, if we want one of these objects to be updated anytime a key is pressed, for instance, there's probably going to be something like that. Then we can, for instance, like the terminal, we would want to know when a key is pressed for the terminal. So we can actually do terminal.handle key press. But we'll need to know, we'll need to define, at least in the terminal, this terminal object, we'll need to define an actual callback function there. You know, same thing for drop-down menu. Right, and the way we can handle all of this state is we can just update, or we can just add new, you know, for instance, if we decide later on the map, for instance, needs to know, or the robot needs to know when a key was actually pressed, we can just add it there. And it seems to be a fairly easy way to handle all of the events, handle all of the state. And this is just kind of how I generally build this kind of stuff out. Okay. We're going to use sockets. You know, I think I'll get into that later. There's no way I'm going to be able to get to all of that. But we are going to be start using WebSockets in order to communicate the front end and the back end together. And so that the front end can know what the state of the robot is, you know, the joint state, and can continually be updated of what's going on with that. That's really helpful with drawing things for in the map, for instance. We might be able to do some stuff with that on the robot side and all that, but we'll get into that at a later time. We're going to create, well, yeah, we'll leave that there for now. So there's one file that I see that we don't have. We do not have, open a new terminal here, ROS workstation source, center tut. I'm going to touch, this is going to be drop down menu.js. I believe that's the file that we need. Let me double check real quick. Make sure that's the actual name. Oh, okay, I see what we've done. We've added that in the viewer class. So that's actually not going to be a separate file. So we don't actually need that right now. We'll probably refactor that later on down the road. But we've got a lot to cover here. We've got a lot to get to. So where to begin? We should at least create the functions or the objects in each one of these, right? So we'll go in here to each one of these files. We'll just do function menu, just so that we've got something here, and that we're not going to start throwing errors the second we start trying to run this code. Each one of these obviously are going to need a step function defined. This.step. We can ignore what the functions file is going to be. Is it's going to be a list of arguments, well, a list of functions that you can call within the terminal. And it's also going to keep track of what the arguments are, how many arguments, and all that kind of stuff. So we can do all the error checking. That way, if you want to add a function, much in the same way that we did with the command lists on the back end, this is kind of the front end version of that. Just some really basic, simple error checking, just so that we know what the actual functions are, and we can do some stuff with that in the menus and the help sections. Okay, so the question now is, well, I'll go ahead and add this as well. Okay, and then with the drop-down menu, oh, this needs to be viewer. Okay. Let's see. Now let's go ahead and run our front end. If we did everything correctly, we'll see a white screen and we'll get no errors. Drop-down menu is not defined. Okay, no problem. That's because, just as I was pretty much saying, function drop-down menu. Okay, so there's all of our stuff built there. Great. No errors. No errors. So now we can look at each one of these classes and we can start going through one by one. Now that we've got the basic framework for everything built out. Yeah, we can start going one by one through here and creating each one of these objects. There's a lot that's going to be going on here. So let's go ahead and create the viewer. That's actually not too crazy. And we can start to see pretty quickly how this is going to work. So the viewer is going to have, we'll do state image. I'm actually making some improvements to this. I don't know why I started doing function. Create image. And we're going to need our camera URL. Our camera URL is going to be that thing right there. So I've got whatever the host name is for the URL that we're at port 8081, and then this is the actual path in order to get there. It's like stream, and then we got this topic argument and type. So we can actually update this with any other topics that we have running on ROS, and it would display that for us. Okay, so what image does for p5.js? This is a p5.js object that we're using here, and that's actually going to display that on the canvas right away. So we're going to immediately hide it, and let's see. We'll go ahead and set the background to 0. And now, with the step, that's where we're going to be updating it and loading the image into the canvas. And that's in p5.js. That's easy. Just call the image class, set the position, or actually set the, pick the image, set the position, and then finally the width, which is just going to be canvas width, canvas height. And both of these are variables that we've defined in sketch.js, which are these right here. So if we reload, cannot set property image of undefined, obviously, because this state is not defined. Okay, great. There it is. I'm realizing, let's see, move over there. Maybe that's a little bit better. I'll move me up here for now. How about that? Well, that's going to throw off. Okay. Well, we'll just do that for now. Maybe in the next video I'll focus on moving me to somewhere else. Okay, so now we've got actually our image drawn and we're moved to the actual space. If we open up ROS and we do like, let's see, ROS topic pub 1, TR1, controller, effort, joint, head, tilt, command, standard messages, float, data, 1.0, we can see it goes up. So we're just publishing data to the ROS topic. And if we do -1.0, it'll go all the way down and we'll be able to see the base. There we go. If we go to ROS topic pub, instead we publish to the head pan ROS topic, we will see that it turns all the way to the right. And if we do +1, we'll see that it goes around the other way. So we can see already how this is working and how this is actually not going to be too difficult to start to build out. All we need to do, basically, is we need to build the commands on the front end so that we can send it back to the server and that the server can publish the data to the ROS topic. You know, there's nothing mysterious here at this point. This is all stuff that that we know how to do. Yeah, so let's see, where else do we want to go? So that might be a good place to start. We're already 32 minutes into this video, and I'm trying to keep them a little bit lower. So we're drawing the data to the front end. We've got all of our objects set up in P5. We've got our sketch function, we've got our ROS launch file, so now we can say, okay, now we've got the basic viewer, we can start to add all of the different modules. I want to add something, you know, like a terminal down here. I want to add a map up to the top over here. You know, maybe some functions over here. I want to have something where if you click on the screen, this happens. That's all easy, just, you know, error or event handling, and then just passing that data down to the back end. And you'll see how that works. That's just using jQuery, using Ajax, and just posting that data to different topics that we've set up on the back end. So, our different routes. And those publish into the ROS topic. So I hope you're starting to see a little bit how this is all going to work. Again, nothing too hairy. I mean, this is all fairly basic stuff. I mean, if you've been a professional programmer, you know, you've done this kind of work professionally, you can jump in here, build these kinds of applications really, really quickly. And that's my whole goal with this series, is just to show you how you can build really cool things with actually not all that much expertise. You know, there's a lot you can take. You know, the TR1 environment, you can take it a long way with knowing not a whole lot, which is super cool. So, thank you very much for watching. This is going to be probably posted on Monday, right? No, this will be posted on Friday, and I think we're going to start with the Monday, Wednesday, Friday posting schedule with this tutorial series. So stay tuned for that. Thank you very much for watching. I will see you guys next time.